Welcome to this technical explainer. Today, we're going to do a complete forensic teardown of PamDOOra. This is a highly stealthy, operator-grade Linux PAM backdoor, and it's designed specifically for persistent post-exploitation. If you're a security analyst, an incident responder, or an infrastructure defender, you are absolutely going to want to pay close attention to the diagrams we're about to walk through. Because as you'll see, this threat fundamentally subverts the trusted authentication boundaries of our Linux environments.
So here is our game plan. We've got 6 distinct phases to cover today: threat overview and vulnerability, the attack chain and trigger, harvesting and sock evasion, forensics and detection gaps, threat profile and economics, and finally, defensive hardening and response. Let's get into it.
All right, Section 1, Threat Overview and Vulnerability. Let's start by mapping out the landscape and pinpointing the exact systemic vulnerability that makes this backdoor so incredibly devastating.
So, what exactly is PamDOOra? Well, as we can see here, it's a $900 post-exploitation toolkit currently being sold on the Rehub cybercrime forum. And the impact is massive. It achieves near-zero detection by aggressively bypassing standard logging. But here's the real kicker: it's actually designed to directly compromise incident response teams right in the middle of their investigations. It does this by exploiting the PAM_exec module for network-aware credential harvesting. To understand how it works, we have to look at the PAM policy engine. Pluggable authentication modules are literally the authentication backbone of modern Linux distributions. It's an elegant system, but it introduces a massive structural risk because it acts as the ultimate choke point, transmitting credential values in plain text to its underlying modules. And since these PAM modules run with root privileges and intercept those plain text passwords before application logging even happens, well, a single compromised shared object file completely subverts the entire system's identity boundary.
Moving on to Section 2, Attack Chain and Trigger. This is where things get really interesting. Let's look at how the lifecycle is structured and exactly how this backdoor fires.
Looking at this flowchart, you'll notice the gray post-exploitation box at the top. The attacker first needs to gain root access through some separate exploit. Once they're in, they deploy PamDOOra and set a passive trigger. Now, the absolute most crucial detail here is that the harvesting phase triggers strictly on failed logins. That means 0 suspicious log entries are created while the passwords and environment variables are quietly scooped up. After that, the evidence is destroyed. This is actually a novel technique that hasn't even been cataloged in the MITRE AT&T framework yet.
And the trigger mechanism itself is incredibly sophisticated. The backdoor actively enumerates file descriptors, resolves symbolic links, and inspects socket metadata like the socket type and protocol. It's looking for very specific network characteristics, a precise TCP port combined with a magic password. This strict network-aware conditional logic essentially blinds passive scanners. It thwarts sandbox analysis entirely, and it completely bypasses standard credential rotation.
All right, Section 3, Harvesting and SOC Evasion. Let's see how this thing actually captures those credentials while simultaneously creating a literal illusion for your security operations center. So the attacker injects a malicious PAM_exec line into the SSHD configuration. But here's the trick. They mark it with the optional control flag. That's the illusion right there. By making it optional, the attacker guarantees their hidden script is going to execute silently without breaking the legitimate authentication chain. The end user just experiences a totally normal login flow, completely unaware that their data was just intercepted.
Because this interception happens deep inside the PAM stack, all that sensitive data, the username, the plaintext passwords, the environmental variables, it's all stolen, XOR encrypted to hide it from defenders, and piped out to an attacker-controlled C2 server. And remember, this all happens before the legitimate SSH auth checker even logs the attempt. Think about the implications of that. If an incident response team logs into that server to investigate, their own credentials are going to be silently captured.
This graphic perfectly illustrates the absolute genius of firing the payload exclusively on a failed login. On one side, your SOC analyst just sees a routine, low-severity failed password log. It requires no action. But on the attacker's side, the reality is that the magic password was accepted, the payload was exfiltrated, and a persistent C2 session was established. There is literally 0 indication of data exfiltration in the system logs.
Which brings us to Section 4. Forensics and detection gaps. The anti-forensic capabilities of this backdoor make incident response a total nightmare.
PamDOOra doesn't just hide, it methodically wipes the forensic trail.
It deliberately alters key authentication logs, like last log, BTMP, UTMP, and WTMP, to completely erase all traces of the attacker's access. It completely distorts the forensic timeline. On top of that, it selectively unsets critical environment variables like SSH connection and redirects the bash history to dev null to totally blind subsequent investigations.
And here is the really scary part. 0 virus total detections for the analyzed malicious PAM samples. How is that possible? Well, first off, the code footprint is tiny. We're talking fewer than 100 lines of code, so there are no massive malware signatures to flag. Second, it relies on modifying native configurations instead of spinning up standalone malicious processes. And finally, it operates entirely within trusted system memory space, which completely circumvents traditional antivirus and EDR tools that are only looking for surface-level exploits.
Moving into Section 5, Threat Profile and Economics. To really understand what we're up against, we need to look at who is building this and the market dynamics driving it.
Threat intelligence indicates that multiple actors are likely using the dark worm alias across the dark web. But our analysis shows that the specific seller pushing PamDOOra on the Rehub forum actually has a medium to high technical credibility. They aren't just copy-pasting code. They demonstrate genuine, hands-on knowledge of Linux internals and realistic tradecraft. This is a highly credible threat actor.
Looking at the economics, the raw source code price recently dropped from $1,600 down to $900. And importantly, buyers are getting the actual raw source code, meaning they can deeply customize it. It utilizes a modular builder pipeline to dynamically compile the payload, and it includes operator-grade features like anti-debugging components. This elevates it way above the basic commodity scripts you usually see floating around these forums.
If we map out the landscape of 22 analyzed open-source PAM tools, we see that about 45% of them are just basic lab-only shell scripts. The ecosystem is basically split between patching modules, capturing credentials, malicious shared object loads, and persistence wrappers. But what makes PamDOOra so unique is that it converges all 4 of those capabilities into a single, cohesive, stealthy implant that is explicitly designed for the wild.
Finally, Section 6, Defensive Hardening and Response. Let's talk about the actionable intelligence and the countermeasures you need to actually defend your Linux environments against this.
System admins, you've got to focus heavily on file integrity and auditing. First, you need to enforce file system level immutability on your PAM directories to stop the runtime insertion of new shared object modules. Second, you must implement integrity monitoring tools like AID to maintain cryptographic hashes of all PAM modules. And third, deploy AuditID with strict dis-astig rules so you can instantly catch configuration deviations.
From an architectural standpoint, remember that PamDOOra needs root access to deploy. You have to prevent that initial foothold. Disable root login, lock the root account, and enforce your firewall rules. Inside the perimeter, you've got to limit SSH key distribution and rigorously enforce multi-factor authentication. And finally, get advanced behavioral scanners like Thor or Wazoo deployed to detect anomalous control flow deviations in your authentication stack.
We're going to conclude with a stark reality and a major paradigm shift for incident response. Because credentials are stolen in plain text during the login sequence, any IR team logging into a compromised server to investigate is going to have their own credentials silently captured. Just deleting the malicious file is not enough. Remediation requires comprehensive credential rotation, revoking all SSH keys, and the host must be entirely rebuilt from a clean state. Leaving us to ask, in the face of operator-grade threats that live silently inside your authentication stack, are your organization's core identity boundaries truly immutable?